Here's a question that drove the early quantum physicists a little crazy. If you try to pin an electron down, really nail it to a spot, the universe just laughs at you. The harder you look, the slipperier it gets. Today we're going to figure out why. First, position. To know where something is, you have to look at it. To look at something tiny, you have to poke it with light. And the smaller the thing, the harder you have to poke. So the very act of pinning down position kicks the particle. Pin li, gikada. Now momentum. If you let position be loose, momentum behaves nicely. Just a few possibilities. But if you squeeze position into a tiny window, momentum suddenly fans out into a whole bouquet of possibilities. Tighter position, wilder momentum. Every single time. This is the trade. You can shrink one of them. You cannot shrink both. Push position down, momentum pops up. Push momentum down, position swells. Nature keeps a budget, and this is the bill. Heisenberg wrote this trade on something the size of a sticky note. Delta x times delta p is greater than or equal to h bar over 2. The uncertainty in position times the uncertainty in momentum can never go below this tiny floor. Why is this true? Because an electron is not really a dot. It is a packet of waves. Make the packet narrow in space, and you need lots of different wavelengths to build it. Lots of wavelengths means lots of momenta. The shape itself forces the trade. Position and momentum are two sides of the same coin. Mathematicians call the bridge between them the Fourier transform. Narrow on one side always means wide on the other. Always. Heisenberg gave us a silly picture for it. Imagine un microscope. To see the electron, you bounce a photon off it, but the photon kicks the electron. Seeing it is hitting it. Hitting it is changing it. Cleaned up, the law uses standard deviations. Sigma x times sigma p is greater than or equal to h bar over 2. H bar is incredibly small, but it is never zero. And the only shape that hits the floor exactly is a perfect Gaussian packet. So remember three things. Position, how well we know where it is. Momentum, how well we know where it is going. And their product has a floor that nature simply will not let us cross. Reality has a budget. Spend wisely.